Hi, Eden. How are you? It's been crazy days, eh?
I know, and I know everyone is tired by now, but we're gonna try not to make it boring. We promise.
We just want to do a recap on our project, Medical Quantum Wonderland, and we want to do it from the beginning. Eden, how did we end up at XPANSE?
Yeah, I mean, it all starting in summer, and as you know, the Quantum Social Lab from the Technical University of Munich, we do, of course, scientific stuff, but mixed up with arts and social implications, and we also link with stakeholders such as the University Clinic of ISAR, and they have such a cool project relating quantum and medicine.
And you may ask yourselves, what can be better than quantum and medicine? Well, we thought, why don't we add arts? Because everyone loves music, galleries, museums. So we thought that with the help of our colleagues, Cecil and Lily, we would explain quantum medicine by using an artistic interpretation. And we thought about Alice in Wonderland. Why? Because it's a magic world that mixes and twists reality, and we thought it's really relatable with quantum world.
Yeah, and I don't know if you were in the booth, but basically it's a two-stage cabin. It's kind of interactive as well, so you will not be pushed a lot of information about just quantum medicine, but it's really interactive and it has a game in it. So we're gonna take you through this journey.
Yes. The first room is the rabbit hole. And why the rabbit hole? Well, at least when I think about Alice in Wonderland, the first thing that comes to my mind is this small rabbit with glasses that runs around the room with a clock because he's late, and he also drives Alice crazy. And in this room is where the user discovers what's the goal of our experience. And it is to defeat the Queen of Hearts, that for us is a tumor. And we want to detect it using second generation MRI. But how can they do it?
Yeah. So the instructions, just like in life, choices are important, and we present the persons a choice between three potions. One of that potion is actually the magical parahydrogen.
Wait, parahydrogen, it's going too far. I think first we should start by explaining a bit what is magnetic resonance imaging. A lot of you for sure have a background that is better than ours, but maybe some of you are not familiar with this term, so let's start from the beginning. Let's talk about particles. Particles have a physical property called spin. You can imagine it as an arrow. And naturally, spins are randomly oriented. You can imagine it as a lot of arrows pointing in different directions. But we can apply a magnetic field by using a very strong magnet, let's say in this direction, and then all the spins will suddenly align to this direction. Some of them will do it upwards, others will do it downwards, and the difference in the amount between the upward spin and the downward spin is what creates the magnetic resonance signal that you can detect. And I think now you can continue with the potions.
I always get ahead of myself, but thank you, Nuria. So we were talking about the three potions, and the first one is kind of a mystical potion, full of color, but like you said, the direction of the spin is important. So it had a ball in the inside with a lot of arrows going everywhere, and it was beautiful just to maybe make it more of a challenge for the people. Not all of them fall. And the second one, it was a brain, very detailed. It was a beautiful figure. And the third one was just like an oval blue molecule-like, but it was not clear that that was the actual solution. So, but then, can you tell us a little bit how the people would know after choosing what they have chosen?
Yes, indeed, in the booth, in the first room, a lot of people asked me right after choosing the potion, am I right or not? But then they had to go through the curious awakening, and it is going through the second room, in which they will see if their solution was the right one or not. So after passing through the desired cut, they would see the wall with the 3 potions that had attached 3 brain images on them, one of them corresponding to each of the potions. So as Eden mentioned, there's this potion that is random, confusing, and this one has a brain image that is blurry, ugly, and doesn't show anything because it doesn't have any magnetic field, so all the spins are randomly, there is no signal. The second potion corresponds to conventional magnetic resonance imaging, and therefore we could see a very detailed brain, but there was no highlighted feature. And lastly, the last potion corresponded to what Eden mentioned earlier, the parahydrogen or second generation MRI, and there the user could see clearly a tumor in the brain because it was representing that with parahydrogen there is the potential of seeing a tumor even in an early stage. And I think now it's a good time for you to explain parahydrogen.
Now is the time. Okay. So what makes parahydrogen so relevant in clinical development and especially for MRI is that, okay, we have to take a step back and say tumors love sugar. And sugar, it's a carbohydrate. And that doesn't look very precise in MRI. Like MRI has a hard time detecting small changes in carbon. So then, but it's really good for hydrogen. So this is why we pair up the parahydrogen molecule with pyruvate, that is a kind of sugar, and then it's like the perfect marriage to feed the tumor, and the tumor then will produce lactate and a lot of energy that the MRI can actually detect. So we're kind of tricking the tumor into giving us the information where it is, even if it's super small. So this is why parahydrogen is relevant.
Yes, actually the research that they are doing at Clinicum Rex de AISA, they are injecting this parahydrogen molecule with pyruvate on mice, and they can see through mapping what is the production of pyruvate and lactate, that is what is produced after you take pyruvate, and it's a very interesting project. I would recommend you to take a look at it if you have time and you want. But now that we have gone through the technical details, I think it's also important, since we are also part of the Quantum Social Lab, to look at the implications in society of this technology. We have seen that quantum technologies has a very important application in healthcare, detecting a tumor, as we have just mentioned, but what are other possible applications of these technologies?
I mean, quantum medicine, as you may know better than us, but you can also think in drug development, in food creation. So everything that has to do with protein expression, for instance, is not just about health, but is super relevant in terms of life and just in the implications for the human race in general to survive.
Yes, actually, there's a lot of applications that we have to discover, but let's jump into the last part of our booth, which for me is one of the most interesting ones because it is about imagining what is the future of these quantum technologies. Like, how can we imagine our future when we introduce these quantum technologies in our daily day? What can you say?
Yeah, I mean, I think we can all relate that if we think about cancer and how it affects a person and the family around that person, of course we want that the solution for the diagnosis is deployed everywhere and for every country and for every person. And I think we saw that in the booth because we had 3 scenarios, and most of the people were super optimistic into voting for that scenario where everyone was included. Of course, we know that life and society has a lot of challenges, and that some countries may not have the solution as rapid as we want, or not all the persons would have access. I hope this is not the case, but of course, we need to be prepared for that scenario so we can close the gap bit by bit. And yeah, simply, I think we can be very hopeful and proud of all the people that went into the booth and shared that same optimistic view, because then we know that we are all thriving and pushing into the same direction. Yeah.
Yeah, because actually the main problem of MRI technologies and quantum technologies is that it's very expensive, and right now I think it's one of the main reasons why it's hard to introduce it in the whole public. But as Eden mentioned, I think we all learned a lot in this experience, that when people know about it, they are really interested, they are really curious, and they are also optimistic, which is surprising for me, I have to say, because during our career, a lot of times they tell us, okay, but this is really optimistic, but it needs time to be developed.
Yeah.
And I think we all had a very nice experience here at XPANSE. We are super grateful for everyone that has talked to us, has given us their opinion, their feedback, and has shown their interest on our project. We feel really grateful to all of us. We are also really grateful for being at this stage and being able to share our experience with you, and we hope to see you in a near future.
Yeah, and also a big thank for our the guidance of Urs Gasser, Philip, Fabian, Marco, as the co-leaders of the Quantum Social Lab in the TUM. And yeah, thank you for being here. Thank you for coming. We hope we see each other in the near future.